Hey guys, I'm back. I'll be creating a series of videos discussing the topics in Calculus 1. Don't forget to follow my page to be updated on every topic that I'll be posting. Kindly share this video to your children, friends, and brothers and sisters to help them learn calculus. So sit tight and enjoy my engineering códigos, the path of becoming an engineer. Alright, so for today's topic, we'll be talking about one-sided limits. So one-sided limit is a continuation of our previous topic about limits. So previously we have already discussed what is limit and how we are going to evaluate a limit. So however, we have not discussed about the concept of when does the normal limit exist and when does the normal limit does not exist. So to answer that question, one-sided limit comes in. So one-sided limit is actually made up of two types. We have the right-handed limit. So the right-handed limit states that the limit of the function f of x as x approaches to a is equal to L, provided that we can make the function f of x as close to L as we want for all x sufficiently close to a with x is greater than a without actually letting x be a. So if you have observed, this definition is actually very similar to the definition of a normal limit. The only difference is the value of x that we are evaluating is greater than a, but take note, it should be very close to a. Okay, so for better understanding, let's have an example. Say for example, we are going to find the right-handed limit of the function g of x as x approaches to 2, where the function g of x is given by the piecewise function x squared plus 4x minus 12 divided by the quantity x squared minus 2x if x is not equal to 2, and 6 if x is equal to 2. So using the definition, we are not interested in this function since we are not actually letting x be a, or in this case a is 2, so we're not interested in this one. We are only interested when x is greater than a, so that means we will use this function. So how are we going to evaluate this one? So simple, all you need to do is plug a value of x here that is very close to 2, but it should be greater than 2. So say for example, let's have your calculator. First, we need to input on your calculator itong equation ito. So we have x squared plus 4x minus 12 divided by x squared minus 2x. So to calculate this one, class, a shortcut way is to use this one, calc. Click nyo yan. So it will ask you what value of x. So we are interested on the value of x that is very close to 2, but it should be greater than 2. So say for example, we'll use 2.1. So as you can see, we will have here a value that is equal to 3.86. Now let's try to have a value that is much closer to 2.001. So as you can see, we are approaching to a certain value, so it's now increasing. So the more we increase the approach value, the more we get closer to 2, the limit will be, your calculator will provide you the limit of that function. So in this case, therefore, the limit of the function g of x as x approaches to 2 is actually equal to 4. Okay, gets ba? Gets na yan. Alright, so let's look now the other type of limit, the left-handed limit. So the definition of a left-handed limit states that the limit of the function f of x is equal to L as x approaches to a, provided that we can make the function f of x as close to L as we want for all x sufficiently close to a with x is less than a without actually letting x be a. So if you have observed, this definition is actually very similar to the previous one, and the only difference is ito, diba? And by the way, if you have observed the limit, meron ditong a negative. This is actually the symbol of a left-handed limit. Tapos yung sa kabila kanina meron lang ditong positive that indicates a right-handed limit, okay? FYI lang. Anyway, let us continue. So let's have an example here so that you can understand what is meant by the left-handed limit. So let's have here, find the left-handed limit of the function g of x as x approaches to 2, where the function g of x is given by this piecewise function. So the same with what we have or what we did previously on the previous example, we will use the substitution of the value of x and it will obtain as 4. So let's try to check that on our calculator. Okay, here we have our calculator, so we need to have a value. It should be less than a, so we'll use a value of less than a. Say for example 1.99, so we'll have here a value which is 4.01. Okay, let's approach to that value. Say for example that one. As you can see, we're approaching to a certain value, and the more we get closer and closer to 2, we will approach to a single value which is actually equal to the limit of this function. So therefore the the left-handed limit of the function g of x is actually equal to 4. Alright, now let's have some fact check. By the way, before that, here is the graph of the function. So as you can see here, from the left hand side, or the value before 2, we are approaching to a certain value which is equal to 4. And also on the right hand side, as we move closer and closer to 2, we will also approach to a single value which is equal to 4. And if you observe here, at exactly x is equal to 2 is an open circle. That means, or as you can see, based on the piecewise function, at x is equal to 2 is actually equal to 6. So this is how we are going to interpret this one. Anyway, that's it. I hope you get it already. So let's have some fact check. So given a function f of x, if the limit of the function f of x, the right hand limit of the function f of x is equal to the left hand limit of the function f of x as x approaches to a is equal to L, then that means that the normal limit will exist, and the limit of the function f of x as x approaches to a is actually equal to L. Likewise, if the limit of the function f of x as x approaches to a is equal to L, then that means that the right hand side limit of the function f of x as x approaches to a should be equal to the left hand side limit of the function f of x as x approaches to a and is equal to L. So ano bang ibig sabihin nitong mahabang definition na to? Simple lang. This is the answer of our previous question. The question is, when does the normal limit exist? By the definition here, it says that the normal limit exists if the right hand side limit is equal to the left hand side limit. So if a case scenario where the left hand side and the right hand side limit is not equal, that means that the normal limit does not exist. Okay? Gets ba? Gets na yan. I think that's all for today. Engineer Kaz is signing off. Bye bye.